main things that I want you to make sure that you can do after this topic. So first thing is native MATLAB data formats, the .mat files. So remember, there's a difference between a .mat file and a .m file. The m file is an executable file. The .mat file is a data file which holds and stores data. You use these types of files so that you don't have to rerun your code to generate data that you have calculated in the file. Sometimes your files could take days to run, and so instead of having to rerun your file to get that statistic that you're calculating or that metric, you save it so you can just access it whenever you want. So there's a couple things we did. Import and export commands for the data, the .mat file is load and save. And the thing to remember with loading and saving is that the variable names come and go when you use those commands. You don't need to say m equals load. You just type load and the data already has variables with it. Does everyone know what I'm talking about? So if you use a non-native format, so one of the Excel read-write commands or the text file read-write commands, when you run that command to, for example, load in an Excel spreadsheet, you have to set it equal to a variable to put that data somewhere. The native format, you don't have to do that. You just load it in, and all of the variables come with the data. So you need to then determine what the variables are stored in there. I have one debugging thing that I've helped a lot of you with, which is this accessing thing. This happens a lot when you're defining new variables and loops, which you did in the topic 6, the lab 6 that you just did. So I have an array that's 1 through 10, so it's just 10 big. If I try to access the 0th element of the array, the error that I get back is that the index must be positive or logical. So you're out of bounds of the array, right? There's no bounds before 1. But the error is kind of, it doesn't say that, right? It says that you need to have a positive or real index. So there's no 0 index, it starts at 1. If you go in the other direction, so if you go too big, so 10 is the last element, if you go to 11, then it says index exceeds matrix dimensions, which I think is a very good error. Like, it makes sense what that error means. So you'll see that a lot, especially in the following topics. You'll see in arrays. Okay, so I'm going to start with going over quiz 6, and I again am going to show it to you with a couple different options for each piece of code. So part 1 in the quiz, the first thing you had to do was load in your data. And so it's a native MATLAB .mat file. So you just use the load command. And and then you need to determine what's in the file. So you can do this a couple ways. You can open up the file in here by just double-clicking on it and seeing what's in it. If you want to do it in your function, when you type load, you can type the word who, and it will tell you what variables your MATLAB space knows about. So I can see that there's 5 variables that were loaded in from that command. So for like part A and B, this would be enough to show, plus like a comment that says which ones that you need to use. So if you went ahead and looked at the different variables, you would see that the temp 1 is the one that's actually holding temperatures, and temp 2 and temp 3 are just, one of them has zeros and one of them has just big numbers. So you were just supposed to find which of those variables was holding temperatures, just to show that you could tell how to look at variables that were stored in a file. Okay, so that was part of it. The second part of the quiz was to count how many of the temperatures were misrecorded as some number. So it was some big negative number. So if I run the code and I stop here, computer's running kind of slow. You can see that for this set of data, I'm just
putting in a logical index, putting the array equal to that number, and it will give me out ones and zeros, ones where that's satisfied, and then I'm just summing the vector to see how many of them were ones. And you could do this quite a few different ways. So what I wanted to show you is a few different options for removing the misrecorded values. So this is the first option I wanted to show you. So this is what most people started with. Most people went and tried to do a loop. So if you try to do a for loop, what I saw a lot of you notice is that you would have an index out of bounds error because you kept removing values from your array, and then your array no longer had those values at the end. So you can't use a for loop because you don't actually know how many times you need to run the loop. So this is a case where you would need to use a while loop if you're going to do it this way. So your while loop is going to be set up just like a for loop, start at 1, and then as long as your index is less than the length, which will get recalculated every time the loop runs. Remember, this condition gets rechecked every time a while loop runs. Then it will just keep updating it. And then you can remove your elements if they're equal to the number. And then if they're not equal to the number, you're going to advance the count. So if they are equal, you don't want to advance I because you just removed an element, so that new element will go in the place that that old element was in. So you want to keep I at the same location. So, and then at the end, I'm just going to check again to see if that count is now 0, and that's a good way to check. So I can run this. I'm not going to run all of them, but I'll just run this first one. So you can see this was my initial count that I printed, and this was the count after the loop. So it took out all of those. There's no longer any with that misrecorded value. Any questions about this one? Let me show you one other way to do a loop if you want to use a for loop. The other way to do a loop is to, instead of removing values, just create a new array and only put values in if this isn't true. Does that make sense? So you go through the entire length of your original array, you initialize a new array as empty, and then you add on to that array as long as the value isn't equal. So that's another option, and then you can just replace the whole array with your new array. Okay, so that way you can do a for loop, but the easiest way to do it is option 2, which is just to use the logical indexing. So you just access the elements that satisfy the condition, plug them into the array, and set them equal to 0. Set them equal to an open closed square bracket. So you can just do it in this one line if you use logical indexing. Okay, so that's the 2 options. Now the rest of it's pretty straightforward because it's very similar to the insert function that we did last time. So part 2 was to rewrite that, but without using open and close bracket. So you can't use that feature that the open and close bracket removes it. So for this one, you just do the exact same thing that you did for the insert function. You're just going to rearrange the elements of the array. So I'm initializing the new array to the same size but 1 less. Last time we did it the same size but 1 more. And then you put in the first elements before the index and then the last elements after the index, and it removes the 1 in the middle. And then you just call that many times just like you did in the other code. You could do this with a loop. I showed you 3 ways to do this last time, so this is just the one way to do it. You can also do this with 1 line just like I did last time if you want to. Any questions about any of that? Okay, so we're going to start plotting today. Just want this to be visible on the video for just a few seconds. So I just printed out, or I just created a little document that has some of the syntax that I'm using today that you can refer back to. Plotting is like on
unlimited options basically that you can do with this. So
I'm going to be showing you a lot of different things, and I just wanted you to be able to kind of keep track of where I was. So what you'll see on that handout is not only the outline of what I'm going to be covering, but also just key functions that I'm going to be showing you how they work. So I have this broken up into 2D and 3D graphics, but I'm only using that terminology because that's what MATLAB uses, but I like to call line plots 1D plots. I like to call the next 2D and the next 3D, but I'll explain that when I get to the volume rendering at the end. But I am trying to be consistent with MATLAB's, what's in the MATLAB help. Okay, did everyone get copies? Oh, the front's still going around. Okay. Okay, so with plotting on your pre-lab and your lab, you're either going to have to make your own data to plot, or you're going to read in data from a data file to plot. So I'm going to show you just simple analytic functions to plot, but all of this is going to work just the same if you're plotting real data. So I'm going to create an array of x values, and then I'm going to just do a sinusoidal distribution for y. So you did a little bit of this in your last in your last lab, but I didn't really explain at all like what it was that you were doing. So now I'm going to kind of show you more what everything means. So the first thing I'm showing you is just the plot command. So when you execute the plot command, so remember anytime you type something, it's just a function or an M file somewhere that's being run. So I'm running the plot function. I'm giving it two inputs. It asks for the x-axis and y-axis data to plot against itself. And the default when you do it is it's going to connect your data points with a smooth line. So it's somehow interpolating between the data that you're giving it and you're connecting it. So that's what is always going to be defaulted. But there's a lot of different things that you can do with plotting. So the first thing is using the command figure. Figure opens up a new figure to plot into. So if you don't open a figure, it will always plot into the previous figure that's opened. So if I do anything above the word figure, it'll go to this window. And if I do anything below the word figure, it'll go to the new window that it's going to open when I run it. So it always will plot to your active figure. At the top of my file, I'm going to type close all because when you're plotting, you want to get rid of old plots so that you're not just replacing plots that are already existing. Or what it will do if you keep typing figure and you run this a bunch of times, you could have like 100 figures opened in your background. So what I always do is just start my code with close all. So there's a couple quick, easy things to do with plotting. The first is to just label your axes. So those are pretty, I think the name of the function is sufficient for understanding what it does. So there's X label, Y label, and title. And when you run it, I should have two figures because I opened up a second figure. It will put the X label, the Y label, and the title directly in there, especially because we're doing this on the projector. But in general, the default font size is pretty small for the labels and titles. You can add a second input to these to change the fonts of the axes or the titles. You can bold them, you can italicize them, you can change the font. They all have different input names here. So font size is what we're going to use here. I also wanted to show you how to change some of the line properties of your plot. So another thing so typically when you're plotting something in MATLAB, it's because you want to put that plot in a report or in a paper or somewhere. You don't just like want it on your screen. So it's really important to have good readability, and the default settings actually are good for your screen, but they're actually not good for any really other place. Question?
So if you have three figures and if you want to put it up plots, you have to have two figures like that?
Yeah, so every time I'm typing figure, it's going to open up another figure window for me, so I'm not going to replace my old information. I'm doing that so you can just, oh, no. I didn't mean to type it twice. Did I type it twice? No, you don't have to type it twice. That would open up two more figures. One would be blank, and then the latest one would open. Is that the other question too?
Just is the F and S font size have to be capitalized?
No, they don't actually. So in MATLAB does have is case sensitive. So if you make a variable that's lowercase, it's not the same as the variable uppercase. But most of these things have been case insensitive. Okay. So I'm going to show you a couple things. So the next thing I'm going to show you is how to change the line width. So as you can see, the default is pretty pretty thin. It's hard to see. It's especially hard to see on the projector. It's also hard to see in reports. It's if you save that variable or if you save this figure, it won't show up if you export this image. And then I'm going to show you a couple ways to change other more general ways to change properties. So I'm going to show you how to change, there's two formats that are used, and one of them is the easy format, that's quicker, and the other one is more difficult but more flexible. It allows you to do it more ways. So for example, there's this quick notation that has actually three different inputs to this single string. So the first letter that you put into this shorthand gives you the marker size. The second one, the letter, is the color, and then the last one is the line type. So right now, I've not indicated a marker because I didn't put one in. So it's not actually going to have a marker for my data points. It's just going to connect the points. I'm choosing red, and then I'm using a dotted line here. So I can show you what that looks like really quick. With the dotted line, it's like not very dark. And then, so that's one way to do it, is it's this kind of shorthand notation. And then the other way to do it is using inputs to the plot function. So for example, if you want to change the color of the line, you put in color, and then you can use the RGB color scheme to decide on what color you want. I think you can actually also use red in a string form, but this is red, red, green, and blue. How much of each? But it's not to 256. You know how like a lot of colors go from 0 to 256 with RGB? It's from 0 to 1. So if you want like 20% red and like 80% blue, then you do 0.2 and 0.8. So a lot of times you have to convert those colors if you want to go find like a really nice color to use. And then if you want to change the line style, which was the other thing I did in the shorthand above, right here, you do line style, and then you put that shorthand in. So that's what that looks like. So these two things these two commands do the same thing. So obviously you'd want to use the shorthand if you could, but for a lot of these types of things you can't do it in the shorthand. If you want to do anything, like for example the shorthand, you can only use 8 different colors. There's only 8 different letters for those colors. And I'll show you that in 1 second. Okay, so if you want to do markers, I'm just gonna change this a little bit. So I'm gonna add a marker. So I'm gonna add an asterisk as a marker, and I'm gonna remove the line. And then I'm gonna replace this line style with marker and put the asterisk there. So these now are going to have scatter plots with no lines connected. And the first one, which one did I do this for? This is the second one. Actually, if I want to remove the line on this one, I have to do line style, and then I have to actually put it to none. Otherwise, it'll default to the original line style. So I'll show you that in a second. So now those two are the same. One is just the asterisk and the R, and the other one you have to use 3 different commands to get it to do that. Any questions so far? Yeah. Yes, so this shorthand goes in order. It's marker, color, line style. So the marker has to go first, the color goes second, and then the line style goes last. So if I wanted a line there, then I could add a line. And I'll show you how you can look up that shorthand. I'll just do that right now. All of this is really well documented, but maybe hard to find. Okay, let's close all these for a sec. So let me show you how to get to it, or how I get to it quickest. So I type in plot, and it is just like a tiny bit slow, but that's okay. It's either called a 2D line plot, and then you're going to go to the bottom here, and it shows a bunch of them. So I just skipped it. Okay. So here are the line style shorthands. Here's the marker shorthands, and then here are the color shorthands. So this is all in the plot help. It does. I don't think it shows you this much when you do that. It only shows you usually the beginning of the help. It doesn't show you everything in that help document. Yeah. Okay. Everyone good with how to change? So you can go on to do anything from here. Okay, I'm just showing you like like how you can change it, but you can change it in any number of combinations. So now what I want to show is how to do multiple plots, a couple different ways so you can kind of understand what those look like. Okay. So the first option for putting multiple things in the same plot, and again, option 1 is always like a little bit quicker, but less flexible. So you can do X, Y, so you put in your X and your Y data, and then you can actually just put in 2 more X's, or one more combination of X and Y. So if this will plot both of these on the same line. I'm just gonna comment all these out so they don't keep coming up. Okay, so that's the first way. It'll plot 2 on the same line. It automatically will change the color every time a new thing plots. But it's a little bit hard to control what the colors or the line styles are when you do it this way, because the only way to do it was with the shorthand. So if I said, no, I actually want the first one to be black and the second one to be red, I could do that, and I could change some of the line style properties, but I wouldn't be able to change everything that I might want to. So the way to do that is to use what's called the hold on command. So what hold on does is if you type plot and hold on, it keeps that figure window open and it doesn't replace, it just adds to. So if I do, let me show you the difference between the two first. So if I don't have the hold on and I run this, what you'll see is in this figure 2, this got plotted, but then this replaced it, this second plot command. So by putting hold on after the first time you plot, then you will have everything after the hold on goes on top of the old plot. And then you either can type hold off, or you can just open a new figure, and then it will just, everything resets, which is usually what you end up doing. Yeah.
So can you put hold on and then after just plug it in and then add another plug?
Yeah, so after you type hold on once, you can put as many things as you want. So I can put in another one. I don't have to type hold on again. And if you don't give it a color, there's a specific order that MATLAB always colors its lines. So it'll just follow that order. All right, so next I wanted to show you the subplot command. And if you're looking at the outline that I gave you, right now I'm on log plots and subplots. So in your lab, you have to do some logarithmic plots, and you have to do subplots. So I want to show you how both of those work. So I'm going to create some new data that is better suited for log plots. My x data is just going to be numbers, but my y data is going to be a set of data that ranges orders of magnitude, which is the reason why you do a log plot. A log plot is used when you wouldn't be able to see enough detail in the plot if it wasn't on a logarithmic scale. And they're used all the time for plotting data because they are oftentimes the best way to plot data. So this is the data I'm going to plot. So let me go ahead and just plot it as is right now. Let me comment out these old plots. Okay. So let me show you what it looks like just without doing anything to it. So what you'll see here is that this big 10,000 number is so big that it stretches your y-axis. So you can't really see the difference between the data points from 3 to 9, right? So it would be nice if you could plot this on a log scale. And there's a couple options for doing that in MATLAB. So what I'm going to show you is the 4 options of plots, and I'm going to put them in 4 subplots. So I'm showing you 2 things at once. The first is something called the subplot command, which breaks your figure up into multiple pieces and allows you to put multiple plots in one figure. So what this command does is this first one is the number of rows, second one is the number of columns, possibly the other way around as well, and then the third number is which plot you're going to plot into. So the first 2 determine the number of plots total, so 2 times 2, it's going to be 4 plots. And then the last number is which one the commands below it plot into. This will make the most sense when I just show you. So I'm going to put some titles so you can tell which ones are going in which direction. So this is a normal plot, and because it's kind of hard to see if I don't increase the size, I'm going to increase the size of the title as well. So let's start with just this. So I'm only going to have one thing go into the subplot. So it broke it up into a 2 by 2 and it put it in the first location. Now I'm going to show you the same thing, but I'm going to put it in the second spot, and instead of doing a regular plot, I'm going to do what's called a log-log plot. A log-log plot will take the log of both of your axes. So that's not actually what would be best for this data, but here you have a log scale and here you have a log scale. So it definitely helps us with our y-axis, but our x-axis is not log scale. It's just 1 through 10. It doesn't range orders of magnitude. Another command that's helpful is grid on, and it actually shows where your ticks are coming from, and that helps kind of visualize the data as well. Okay, so the other 2 types are obviously just doing a log on one of the axes. So this is typically what you do. You don't usually need a log on both, but I'll just show you each of them. So this one, I'm going to do semi-log x. Semi-log x makes the x-axis log. And then this one, I'm going to do semi-log y. And so this is the one that will be most useful for this data. So here is all 4 subplots filled, and each of them with a different log axis. So this is normal, this one has log on both, and then these are the 2 that I only did one of the axes. So this looks best, right? You can see the data best with that combination. So in your lab, you are going to do this with some of the data as well because it's spanning orders of magnitude. Any questions about the set? And really the subplot, like don't memorize like what the first number and the second number, just like, you just try it and you can tell where it's gonna go. None of this stuff needs to be memorized. I'm not testing you or ever on memorizing all of the plotting options in MATLAB. I want you to just be able to do them. Okay, I'm gonna comment out these subplots and I'm gonna move on to the set command. So if you look at your outline, now I'm on the set command. The set command is probably the most useful thing to understand with plotting because it's the one thing that really allows you to do just about anything in your plotting. So I'm going to just use the data that I just created, the x1, y1 data again. And I'm going to plot it twice because I want to show you a couple other things that I need 2 plots up for. So I'm just going to put in x1, y1, and then I'm going to double the y2, so I have 2 lines on my plot. Okay, so let me just give you the syntax for the set command. And this is something you can see, and I'm going to show you in the help how this works. But the set command has 3 inputs. The first input is it's like the handle that you're going to access. So it's either that you want to access the plot that you just plotted, you want to access the axis of the plot that you just plotted, or you want to access the figure. So it's a little bit confusing, but I hope that we can at least see, you can kind of like start to see how it works, and then you'll have to play around with it a little bit on MATLAB. So when you execute the plot command, if you give it an output to go to, it will basically hold the handle of the plot in that variable. So right now, I'm using P as my figure handle. And then what I'm going to do is I'm going to type that handle that I defined. And then I can choose any property to change. So let's say I wanted to change the color of the lines in the plot. This is the 3rd way to do it, which is to access the plot handle, use color, and then change it to red. You'll notice that the notation for every single way to change the color is a little bit different. But all it's going to do is it's going to access whatever's in that plot, and it's going to put all of the lines to red. Now this one isn't very useful because there's an easier way of doing it, but that's how the command works. I wanted to show you this because in your code you need to do this in your lab, change something that you can't change in the plot command. You need to use the set command. So what I wanted to show is how to change the tick marks. So you'll see that the default is that every x value has a tick mark. So there were 10 x values, so do you see how all 10 are showing up? If you want to change that, you can always use this command called GCA, which stands for the current axis. So instead of giving your axis a name, you can always use GCA, and it will just give whichever one is in the active figure. And then you can change a lot of things that you can't change any other way. So one way is you can change the tick values. So what I'm going to do is I don't want every number to show as a tick value. I only want every other. So you'll see that when you do the set command that way, it's only going to show every other tick mark instead of every. I guess it's not the even ones because they started at 1. So it's 1, 3, 5, 7, and 9. So that's to change where the ticks are. And then what you need to do in your lab is you need to show or you need to change them to actually to strings. So let's say instead of numbers, I just wanted to put ABC as my ticks. I can create an array that holds 5 strings, and then I can use the set command. And then instead of using xtick, I'm going to use xtick label. And then I'm going to access the variable xtick name. And what that will do is it'll replace all those tick marks with strings. Now these are a little bit hard to see, so if you want to change the font size of your entire axes, you can just set everything that's in the axes that's labeled to a higher font size as well. And so that's a pretty quick way of changing that. And then with the set command, I also wanted to show you how to change figure properties as well as axis properties. So in addition to GCA, there's also GCF, which is your current figure handle. And there's a lot of things you can change in the figure. One that I almost always change is the color of the figure, because when you export in some formats, it doesn't look, it has that gray background, which is not very nice. So you can change the background to white. You can change the name of the figure. You can change anything about the figure as well. So that's what GCF does. Okay, yeah.
Do you always have to name the tick marks in a string?
No, you can use numbers too. You could change the no, you'd have to use them as a string. Yeah, you would. Yeah, you can't change them as a number. The next thing I wanted to show you is how to annotate your plots. So this is something you have to do in your lab. Annotating your plot just means putting text somewhere on the plot. So the function is called text, and then you just put in the XY location where you want the text to go. So I'm going to put this on the x-axis at 3 and on the y-axis at 100. And then you can just put in a string, and it will annotate your figure with whatever text you chose. I'm going to choose something a lot bigger. And it's really small font as a default, so just like with the other things, you can change that font. So let me make it a little bit bigger so you can see it. And so you'll have to do that on yours to point out some locations as well. Okay, so I'm going to show you a few things with 3D plotting. Okay, so the first thing on the bulleted outline that you'll see is I'm going to show you how to create 3D data. So for this one, I'm going to show you how to do it in 2 ways. So the first way, and I'm actually going to copy over this code because it's probably going to take me a while to write this down, and I want to show you this, and you can go back and look at the details if you would like to. Okay. Okay, so when you're doing 3D plotting, you're going to have to, a 3D plot means that you have an X and a Y and then something you're plotting versus X and Y. So think of it as like an elevation map if you're hiking or something. So it's something that varies in 2 dimensions. It's not something that varies in 3 dimensions, if that makes sense. So I'm going to create an X and a Y, and then I'm going to define a Z based off of that. So think of the Z as like a height that is varying in X and Y. So when you think about it that way, you have this field of X, Y, right? And you need to come up with a height for each combination of each X and Y, just like a 2-dimensional function, right? So to do that, define 2 vectors, X and Y, and then pre-allocate your Z that's going to be the same size as that x and that y, but the square root of that. And then what will make sense to most of you is to create a loop and just have a nested double loop that gets every combination of the I and the j. So that's kind of like what was on the quiz, if you remember doing that, that little picture of slashes and hashtags. It's kind of like that. So that's one way to do it. And so that will just create a 2D field that's z that varies with x and y. However, MATLAB has a much quicker way of doing this so that you don't have to write this loop every single time, because what you're really doing is you're trying to get for one x all the y's, for the next x all the y's, right? That's what you're trying to do. So it has this feature called mesh grid that takes your x and your y and it meshes it. So it gets every combination meshed together. So let me show you in the command window what that looks like. So I'll just do it with like a really short array, because this really makes the most sense when you just see it with an example. So when you put in the x and the y into mesh grid, it will output an x and a y out, and all it's going to do is it's going to take your x and repeat it for the number of y values there are, and it's going to take your y array and repeat it for the number of x values. So if you were to multiply those two together, you would get all of the combinations. Yeah?
X only has 3 values, so why did y show up with 4?
So x has 3 values, so this is the x and it was repeated 4 times. And then y has 4 values and it was repeated 3 times, which is the size of x.
Oh, okay.
Yeah. And so that way you can use vector notation to define c using the dot operator. But this c and this c are the same thing. So I can show you that. I'll plot them both next to each other in 2 different plots. So I'm just going to create a subplot, and I'm going to do a contour plot of each. So one of them is plotting z, and the other one's plotting capital Z, but you see that they give you the same thing. So the function that I'm using for this is contour f, and contour f is a filled contour, and the 3 inputs are x, y, and z. And you can also do regular contour with no f, and the regular contour with no f just doesn't fill it in with colors, it will just do the contours. Any questions about that? There's a lot of other things you can do with the contour plot. For example, you can add additional contours to show up as the 4th input if you want to show more of the lines. You can show a color bar, which will give you values, will report values of those colors. So here it's showing not only it shows what the colors mean, basically. And then another thing you can do is you can change the color map. So the default is actually usually jet. I don't know why it's not showing up as jet. I must have changed my settings. So this is probably what it will look like for you guys when you run a contour. Oh, maybe that is the jet contour. But there's a bunch of different color maps that you can look up. You just look up color map, it'll show a bunch. Oh, I'm not using color map, I'm using color. So let me go back to jet. So jet's like the standard blue to red color map with yellow in between. It's usually what everyone uses. It's not actually a great color map, but I don't know. That's the one that's usually used. And then the last thing I wanted to show you is a surface plot. So surface plot is just surf is the command, but everything else is the same as the contour plot. And a surface plot, instead of looking at, so the contour plot is looking down in this direction here, and the surface plot will show the 3D. And if you want it to look like the picture that I showed you in your lab, you'll have to type shading and terp, which smooths it out and takes out those black lines. It just looks a little bit nicer. Okay, that's it. Thanks.